Chapter 10, the two sample confidence interval. So we have three formulas in chapter 10, and this is 10.1, 10.2, and 10.3. The way for us to recognize which formula to use is we read the problem and see that are they talking about the confidence interval for the mean or for the proportion and the means and match pairs. For example, the first one, section 10.1, problem 15, we have the question asking us to construct a 95% confidence interval for the mean. So we will use this one. You haven't seen the match pairs yet, and you will see that in later. So we use the 10.1 formula. Okay, so now let's read the problem. A group of 78 people enrolled in the weight loss program that involved adhering to a special diet and to a daily exercise program. After 6 months, their mean weight loss was 25 pounds with a standard deviation of 9 pounds. A second group of 43 people went on diet but did not exercise. After 6 months, their mean weight loss was 14 pounds with a sample standard deviation of 7 pounds. So let's write down the given information. You have two groups, group 1 and group 2. The first group with the same program, but they do not exercise. The exercise, and the second group no exercise. So we have N1 is 78, X1 bar is 25, and S1 is 9. The sample size for the group number 2 is 43 people. The sample mean is 14, and S2 is 7. We use the formula is the point of estimate plus minus margin of error. So that is X1 bar minus X2 bar plus minus T square root of S1 square divided by N1 plus S2 square divided by N2. So 25 minus 14 plus minus square root of, you plug in a number, 9 square divided by 78 plus 7 square divided by 43. Now we need to find the T and form the confidence interval 95% in the problem given. So we have 95% is here. So you draw 95% in the middle, and the tail should be 2.5% in each, and that is 0.025. The degree of freedom, we will choose the smaller one. So the n is 78 and the n 43, we will choose the smaller n. N is 42. So then we go to the GeoGebra. GeoGebra Classic. And then we choose the student. We input 42. And we can use the right side or the left tail. Okay, so we input the alpha, which is 0.025, and I got the number is 2.0181. Then you put this whole thing in the calculator, GeoGebra calculator. And how do I do that? Okay, so 25 minus 14. And then I do the minus first. 2.0181 square root. Now you do fraction 9 square. Now you go down in the bottom is 78. You will choose the arrow on the third column, on the second column from the right side to move it, okay? And then fraction, and then plus fraction 7 square divided by 43. So I got the answer is 8.02. Then you just go ahead and change the minus side in front of the t, which is 2.0 something, to the plus. Then you got 13.9783. On the test, I will tell you how many places for you to route. Okay, so that's it. Then we will answer that we are 95% confident that the mean difference, okay, how do I answer? So actually I just need to copy the mean difference in the weight losses is between 8.002 and 13.98. So we can solve this problem using the GeoGebra. You click on statistic, and then you will choose the estimate is for the confidence interval. So we will choose the t estimate difference of the mean. The confidence interval is 0.25. The mean is 25. The standard deviation is 9. The n is 78. The mean here is 14. The s is 7. And the n is 43. Then you got the lower and the upper. The lower is 8.07. And the upper is 13.9. We have a little bit off from our manually work. The reason why is you look at the degree of freedom. The degree of freedom that we got is 42, and the degree of freedom in the GeoGebra is more exact, is 105. The reason for that is that they are having the formula for the degree of freedom, and because that formula is very complicated, so we use, for manually work, we use the degree of freedom. We take the smaller one, which is 43 minus 1 is 42, is similar, and that's still acceptable. Okay, so which one is more exact answer? I would say this GeoGebra will be more exact answer.